Hello students, in today's important lecture we will study the displacement, velocity and acceleration diagram when the follower moves in following three important conditions which are the part of our syllabus. The follower, in case of follower arrangement, travel and the travel is in the form of up and down motion, and the follower motion takes place according to the three important condition. First condition is uniform velocity. This is the first condition. Second condition is simple harmonic motion. This is the second condition. And third condition is uniform acceleration. And fourth condition is also there, that is called cycloidal motion, but in our syllabus this condition is not we have to study. So let us understand how to plot a displacement diagram or displacement velocity acceleration diagram when the follower moves with uniform velocity. So here in this picture you will see these three graphs. Graph A is displacement diagram, graph B is velocity diagram, and graph C, here you will see acceleration diagram. And in that the x-axis is called as an abscissa and y-axis is called as an ordinate. So abscissa is representing angular displacement of the cam, and the ordinate is, in first case you will see the displacement on y-axis as an ordinate, velocity is another ordinate on y-axis, and acceleration is another ordinate on y-axis. But on x-axis you will see the abscissa as an angular displacement which is common in all these three diagrams. So first diagram is displacement diagram, second diagram is velocity diagram, and third diagram is acceleration diagram. And these three diagrams are for the condition when the follower moves with a uniform velocity. So the displacement, velocity and acceleration diagram, particularly when a knife-edged follower moves with uniform velocity, is shown in the following figure. So as I said, the base, or we can say abscissa, represents the time or the number of seconds required for the cam to complete one revolution, or it may represent the angular displacement of the cam in degrees. So abscissa or x-axis represents the number of seconds required for the cam to complete one revolution, or angular displacement of the cam. It may be also called as an angular displacement of the cam, and it may also represent the, what we can say, the time, or the time. Okay, it means that the number of seconds required for the cam to complete one revolution. Now let us see the details. Since the follower moves with uniform velocity, this is the first condition, and the follower moves rise in upstroke and downstroke. So the follower moves with uniform velocity during its rise and return stroke. Therefore the slope of the displacement curve must be constant. So here in this figure particularly, A to B1 and C1 to D must be a straight line. So you will see that inclined straight line A to B1 and C1 to D, these are the two inclined straight lines which is representing the rise and up motion of the follower and down motion, which is called as a return stroke of the follower. A little consideration will show that the follower remains at rest during some part of the cam rotation. The periods during which the follower remains at rest are known as a dwell period. So on this particular axis you will see that A to E, This abscissa is divided into A to B, B to C, C to D and D to E. A to B is called rise, B to C is called as a dwell, C to D is called as return, and again D2 is called as a dwell. So here what do you mean by dwell? Means the period during which the follower remains at rest are known as a dwell period. So in this figure, B1 to C1 and DE, this is nothing but the dwell period. We see that the acceleration or retardation of the follower at the rest, beginning and at the end of the stroke is infinite. If you see below to that, there is a velocity and acceleration diagram. First diagram is displacement diagram, second diagram is velocity, and third diagram is acceleration. Now in case of displacement diagram, A to B1 represent the rise or up motion of the follower, B1 to C1 is called as a dwell period, C1 to D is called as a fall or return stroke of the follower, and D to E is again the we can say dwell. Related to this particular portion, we will have the velocity. See, the velocity is uniform during the period A to B1 and during the period return stroke C to D1, C to D. There is no motion between B to C. There is no any kind of phenomena that is occurring between we can say between the region B and C. And in case of acceleration diagram, you will see the infinite acceleration during the AB and during the CD region. So we can see that the acceleration or retardation of the follower at the beginning and at the end of the each stroke is infinite. This is due to the fact that the follower is required to start from rest and has to gain a velocity with no time. This is only possible if acceleration or retardation at the beginning and at the end of each stroke is infinite. These conditions are impracticable. You will see that sudden there is an infinite acceleration, and this is happening because the fact that the follower is required to start from rest and has to gain the velocity within no time. That's why the acceleration is infinite, and this is impracticable. But below to that, you will see the modified displacement, velocity and acceleration diagram when the follower moves with the uniform velocity. The velocity displacement diagram is as it is, but at the end, at the start of this region, we can say rise of the follower, there is a slight curve given, and similarly during the line C1 to D, you will see that slight curve. So this is nothing but a modified displacement, velocity and acceleration diagram. You will see the modified velocity diagram also, modified acceleration diagram also. So in order to have the acceleration and retardation within the finite limit, it is necessary to modify the conditions which governs the motion of the follower. This may be done by rounding off the sharp corners of the displacement diagram. So sharp corners are modified here and this may be done by rounding off the sharp corners of the displacement diagram at the beginning and at the end of each stroke. By doing so, the velocity of follower increases gradually to its maximum value at the beginning of each stroke and decreases gradually to the zero at the end of the each stroke. The modified displacement, velocity and acceleration diagram is shown in above. Means here this is the modified diagram for uniform velocity. The round corners of the displacement diagram are usually periodic curves because the parabolic motion results in acceleration of the follower for a given stroke and cam speed. So in this way we studied here the displacement, velocity and acceleration diagram when the follower moves with a uniform velocity. Thank you.